Hello, welcome to this video. In this video, we will discuss transformations. And you've probably done this before. Most students have done this before when they have worked with transformations. And all that really means is that we're going to move things around. We're going to take a graph that's given to us or some type of equation that represents a graph, and then we're going to move it around. Okay, so this chart gives you sort of the breakdown of what each type of transformation means. And so, like if you have a number added on to the backside of the function here, that's telling you to go up that many units. So like if this was f of x plus 2, we would be shifting up 2. So you would take everything on the graph and you're going to move it up 2 units, okay? If you have a minus, then that's down, okay? If you have an x plus c, notice that the plus c here is inside the function. Notice it's inside that function. That actually means that you want to move it to the left. And then if you have a minus c, that's going to be to the right. These are actually feels a little backwards. You'll see that when we get down to an actual example. If the negative is on the inside of the function, this is you're reflecting across the y-axis. I also tend to call that a horizontal reflection. Horizontal reflection, and you'll hear that reference in the lab manual and whatnot. If the negative is on the outside, then that's a reflection over the x-axis, which is actually like a vertical reflection. Okay. Now, if you have a number being multiplied to the function, okay, then it depends on what this number is. If the number is a fraction, so it's between 0 and 1, that gives us what we call a vertical shrink or a vertical compression. You'll hear the word compression sometimes. If that C value is greater than 1, then that gives us a vertical stretch. All right, so that can go different ways depending on what you're working with. If you have a number inside, it's multiplication, but it's inside the function. Same idea, it depends on what the number is, but it is opposite from what we saw in the previous. If the number is between 0 and 1, this is actually a stretch, whereas up in this previous situation, that was a shrink, right? And then if the number is greater than 1, that's a shrink, okay? So it's backwards from what we did in the previous, okay? Like I said, this will make a little bit more sense when we actually do some examples. So if you just want to think about using some regular numbers here, so if we're working with an f of x function and we want to indicate that we're going to take that function and we're going to shift it up to, a vertical shift up to, we would write y equals f of x plus 2. Okay? And you're just kind of adding that number onto the back of the function. If you want to go down 3, we would say f of x minus 3. If you want to say that you're going to the right 2, okay, the right 2, you would say f of x and you would say minus 2, and notice it's inside the function here, inside those parentheses. And this does feel backwards, right? Because we think of going to the right as adding or being like a positive change, but you notice you use the minus here. So that is a little backwards, okay? Be careful for that. Similarly with going to the left, sort of feels like you should use a minus, but you use a plus. Okay, so this would tell you to go to the left 2. A reflection over the x-axis, which is a vertical reflection, you would put the negative out front of that function. And a reflection over the y-axis, which is the horizontal reflection, the negative would be inside the function. Okay, if you have a vertical stretch, then you would need a number multiplied to the front of the function. So like if you're stretching by a factor of 2, you would use a 2. If you're stretching by a factor of 3, then you would use a 3. Okay, and both of those would tell you a vertical stretch. A vertical compression, the number out front will just be a fraction. Okay, so like if you have a 1/2 out front of the function here, that would tell you you're compressing or shrink, right? That's what they called it in the chart up there, shrink. Okay, and if here, let's say if it was a 1/3, that would tell you a vertical shrink or compression. Now, a horizontal stretch is really backwards from what makes sense. So if I am stretching by a factor of 2, I actually use a 1/2, okay, inside the function here. So 1/2 tells me that I'm stretching the function, which seems very backwards, right? And if I am stretching by, say, a factor of 3, I would use a 1/3 inside that function. Okay. Now, a compression or the shrink is the opposite of what we just did. So if I need a compression of, let's say 1/3, or so let's say 1/2, excuse me, a compression of 1/2, I would use a 2 inside the function. And that tells me to compress the function by a factor of 2. And then similarly, if I need to compress the function, I would actually use a 3 here. And that's telling me to compress by a factor of 3. So these are backwards, right? This is backwards, this is backwards. Also, these, the left and right feel backwards. So you got to watch out for those. They sort of go against, I think, what your intuition would tell you to do. So if we keep moving along here in the handout, the back side or the second page discusses how you would go about doing multiple transformations if they're presented to you in a function, which is typically the case. Typically, you're going to have more than one transformation indicated in the function. So if you look at what they gave us here, they gave us this f of x function, and then they gave us this transformed function here. I'm going to write that up here where I have a little more space. So that's a -2 f, and then you have a -1/3, and then an x plus 4, and then a plus 5 on the end there. Okay. So what's happening here, if we take this f of x function that's given to us, okay, this f of x function, and I do all these transformations to it, and I do them correctly, okay, we don't make any mistakes, and I do them in the correct order, by the way. You have to be careful with your order. I should end up with this guy right here, okay? So basically, I'm giving you the beginning and I'm giving you the end, and we're going to talk about what happens in the middle, okay? So first off, you want to just take your original function. You want to find a few points on the function that you can identify. So like 0, 0 would be a good one, 1, 1, and 2, 4. And I generally like to write those down. Okay, so 0, 0, 1, 1, and 2, 4. Okay, make a little table of values. Okay, and then we want to think about the transformations that need to be done, and we want to think about doing those in the correct order. You can't just start moving this thing around any old way you feel like doing it in any old order you want to do it. Okay, you have to follow the specific order of operations. Okay. Now, these kind of work like PEMDAS. I don't know if you've ever heard, please excuse my dear Aunt Sally. But you kind of start within those parentheses so that kind of the inside of the function. And when you're inside there, you follow these order of operations. And then once you're done with the inside of the function, then you work your way out. So some people like to think about PEMDAS, but if that confuses you, don't worry about it. Just memorize these steps. But generally, you want to start with in any horizontal stretch compression or a horizontal reflection. Okay, so if you have these, right, if these are indicated in the given transformations, you want to do these first. And it doesn't matter which one you do first. If you want to do your stretch or compression first, that's fine. If you want to do the reflection, that's fine. It doesn't matter. It's your choice, okay? So if you look at what we have here in our given transformations, we have this -1/3 inside the function, and this is telling us that we have a horizontal reflection and we have a horizontal stretch of 3, okay? So we have both of these, right? We have this stretch and we have this horizontal reflection. Okay, remember this 1/3 feels like it should be a compression, but that's backwards. So it's actually a stretch. Okay, so let's actually go through those steps. Okay, so let's do the reflection first, the horizontal reflection first. So what's going to happen, okay, is we're going to take this and we're going to reflect it over this y-axis. So like this point 1, 1 here is now going to be at negative 1, 1. And this point 2, 4 is going to be at negative 2, 4. And then 0, 0 just stays right where it's at because it is right on the axis, okay? So just kind of lightly sketch that in on your handout, okay? So this is what we have. And what happened is these x values just flipped the sign, right? If they were positive, they went negative, and 0 stayed 0. And our y values did not change. So that is our horizontal reflection that we just did, okay? Now we need to do our horizontal stretch, okay, our horizontal stretch. So I'm going to take these points that I just got, I'm going to switch to a different color here. So let's go maybe red. And I'm going to stretch these out. So this point here that is at negative 1, 1, okay, now it's going to stretch out and it's going to be at negative 3, 1. Okay, so think about multiplying that x value by a factor of 3. Okay, and this x value that is at negative 2 here, I'm going to stretch that all the way out and it's going to be at negative 6. So think about multiplying the negative 2 by 3, okay? And then the point at 0, 0, 0 times anything is still 0, so that stays right where it's at. So I'm going to try to lightly sketch this in. It's kind of hard to use this pen. It's a lot easier with paper and pencil. So yours hopefully will look a little better than mine. This stylus tends to kind of jump around, but it's going to be something kind of like this, okay? And I'm only making them dotted to just kind of emphasize you want to kind of just make them light, light on your paper because otherwise it gets a little crazy. So back to our table of values over here, the 0 stayed 0, the negative 1 changed to a negative 3, and the negative 2 changed to a negative 6. And what we did right there is we just multiplied by a factor of 3. We just said times 3. And we did a 3 because of this 3 that was sitting in that fraction, okay? And the y value stayed the same, okay? All right, so let's keep trucking along here. The nice thing about videos is if I'm going too fast, you can always just pause it, right? Okay, so now we have taken care of the negative 1/3. We want to stay inside this function, continuing to do whatever else is in there. So that brings us to dealing with this 4. Okay, so this is a shift to the left 4, left 4. Okay, so what we're going to do is I'm going to switch to a different color here, and let's go with this light blue here. Okay, and everything needs to move to the left 4. So if I start at this point here, the negative 6, 4, and I move it to the left 4, 1, 2, 3, 4, just think of counting over, you're going to be at this negative 10, 4. And you go to your point at negative 3, 1, and think of moving that to the left 4. 1, 2, 3, 4. You're going to be at negative 7, 1. And then your 0, 0 point will now slide over to negative 4, 0. So everything just moved to the left 4. And then kind of just lightly sketch that in. Try to maintain the same kind of general look of the function. Got a little curve to it, not a lot, but Okay. And then it's always a good idea to jot down your point somewhere. So our point that was at 0, 0 is now at negative 4, 0. And our point that was at negative 3, 1 is now negative 7, 1. And our point that was at negative 6, 4 is now at negative 10, 4. So our y values still did not change, but our x values did all shift over 4, and that was like subtracting 4, right? So if you think from here to the next step, you are subtracting 4, right? And that's how you get to these new x values. All right, so let's keep trucking along here. So now we are at a point where we would want to do any kind of vertical reflection and vertical either stretch or compression. So on this one, we have a vertical stretch. That's what that 2 is telling us. And we have a vertical reflection. That's what the negative out front is telling us. And it doesn't matter which order we do these. If you want to do the reflection and then the stretch, or the stretch and the reflection, it does not matter. It's completely up to you. Okay, so I'm going to draw out a new little XY chart over here. Okay, and let's go ahead and do the vertical reflection. So what's going to happen here is, I'm going to go to a green here, is everything's going to flip over the x-axis. Okay, so this point that's up here at negative 10, 4 is now going to flip over, and it's going to be still at negative 10 for the x value, but now it's going to be at negative 4. It's going to flip, okay? And this point that's at negative 7, 1 is going to flip over the axis, and it's now going to be at negative 7, negative 1. So, okay, it's flipping down here. And any point that's on the axis just stays on the axis. So this point at negative 4, 0 will just stay right there at negative 4, 0. And then this is my new curve. I'm kind of lightly sketch this in here. Okay, like I said, try to maintain the same look of the function. It should just look like it flipped over the x-axis. My new points are negative 4, 0. Okay, that stayed where it was. My negative 7 stayed negative 7, but now I have a negative 1 instead of the positive 1. And my negative 10 is still negative 10, but instead of 4, now I have a negative 4. Okay. And what happened there, if you think with our y values, is just like multiplying by a negative 1, right? Just think of taking each of those values and multiplying by a negative 1, and that flips them right over that x-axis. And that's what we call a vertical reflection, because it changed vertically, like, okay, it flipped over the x-axis, okay? Going back to our function, we're almost done. We've got 2 more steps. We still have to do this vertical stretch. So we're going to do a vertical stretch using a 2. All right, so let's make another table of values here. Okay, and then you can come over here and look at your graph. I'm going to pick a different color. Maybe you have a highlighter at home and that you're kind of using a highlighter. That would work well. And so these are going to stretch. So it's kind of like what we did when we did the horizontal stretch, except for when we did the horizontal, the x values were changing. Now our y values need to change because this is a vertical. So this point that's at negative 2, negative 4, okay, you want to think about that's going to stretch to negative 2, sorry, not negative 2, negative 10, negative 8. So it's going to kind of stretch way down, okay, go lower. And our point that's at the 7, negative 1 now is going to stretch to negative 7, negative 2. Okay, and if a point is on the axis here, like this negative 4, 0, it just stays on the axis. Okay, so let me sketch this in lightly here. Okay. And let's talk about our table of values. So what happened is our negative 4, and this point negative 4, it stayed negative 4. And the y value actually stayed 0 as well. The point that was at negative 7, okay, now instead of a y value of negative 1, it has a y value of negative 2. And my point that was at negative 10 still has a negative 10, but now instead of a negative 4, I have a y value of negative 8. So think about what you're doing right there is you're actually just multiplying by 2. You're multiplying by 2. So whatever these y values are, because it's a vertical stretch, you can multiply those by 2, and that will get you your new y values. All right, our last thing that we have to take care of here is this 5 that's on the end of the function. And this is a easy one here at the very end, and we're going to do this vertical translation, which just means you do any up or downs at the very end. And so this is telling us to move everything up 5. Okay, so take everything, any point that we have, move it up to 5. So I'm going to switch to the black now. Okay, so actually, let me make one more table of values. Okay, and then with my graph, I'm going to switch to black. And remember, they gave us the answer, so we kind of know what we're trying to get to here. So you want to just think about this point that you had here at the negative 10, negative 8. You want to think of moving that up 5, which will take us right here to this negative 10, negative 3. Okay, and then our next point here, which is the negative 7, negative 2. Think of moving that up 5. 1, 2, 3, 4, 5. And that'll take us, whoops, whoa, my pen went crazy on me there. Let me try that again. Take us to this point right here, which is negative 7, 3. And then this point here at negative 4, 0. We move that up 5. It's going to take us right here to this negative 4, 5. Okay. So on my table of values, what's happening is my x values did not change. So my point that was at negative 4, 0 still has a value of negative 4, but now the y value is 5. And my point that had an x value of negative 7, I want to think of adding 5 to that negative 2. So now that's at 3. And my point that was at negative 10, now take that negative 8 and think of adding 5 to that, and that is the negative 3. So that's my new points here. And if you're thinking about what happened is I took these y values and I added 5 to them, and that gave me these new y values here. Okay. So we did indeed get to, right, this final function, which we kind of knew when we started the problem, this is what we were trying to get to. All right. But you can see a lot of things happened here, right? We don't usually give you ones quite this hard where it involves so many transformations, but it is a good idea to sort of understand that you do have to follow a certain order, right? And you just keep working off of each step. So you do one step, and then the next set of points is generated off of that step, and then the next set of points is generated off of that step, and so forth. And it just progressively builds up.